Okay, so in this video, we're going to talk about parabolas. But before we do that, I want to just review really quickly ellipses and circles. So by definition of an ellipse, it is the set of all points, right? So it says that here. Just like in class, I lose my mouse. All right, the set of all points. That's important because every single definition on all of the conics has that in the definition. So it is the set of all points. It is the set of all points that, if I pick a random point here, let's pick this point right here, x, y, and I take the distance from here, and I take the distance from here to the two foci, pick a way to say it. I looked it up, both work. And this is distance 1, and this is distance 2. D1 plus D2 is the same number, is constant. So if it was like D1 plus D2 is equal to 10, then the entire time, if I move it this way or if I move it this way, it will always be equal to 10. If it's 20, it will always be equal to 20, okay? So let's go over what a circle is. Circle is by definition, if I take a random point, if we pick this bad boy right here, x, y, and I find the distance to the center, that is going to be the same number called r, which is for radius. So let's talk about let's talk about what the standard forms are for both of these, because I want you guys to see the similarities between them and realize that the standard forms for parabolas and hyperbolas are all going to be in the same similar format. Okay, so if I have a horizontal ellipse, meaning it looks like this, it is horizontal, it is longer horizontally, it is going to look like x minus h squared, right? And it's going to have a plus y minus k squared, and it's always going to be equal to 1. But if it's horizontal, that means that this distance horizontally is a in the x direction. So I know a is going to be underneath x and b is going to be underneath y. And then if I have a vertical ellipse, meaning it looks like this, meaning a is vertical, then that means it's going to be x minus h squared. And again, I have y minus k squared equals 1. And a is vertical, so a is going to go underneath y, and b is going to go underneath x. So those are my standard forms, both of them, for a horizontal or a vertical ellipse. So fair warning, with parabolas, there's also going to be horizontal and vertical forms, also with hyperbolas. The only one that does not have more than one standard form is circles, English. So what is the standard form of a circle? So it's going to be x minus h squared plus y minus k squared equals r squared, where r is your radius. So these are your three standard forms. Please notice all three of them have x minus h, y minus k, x minus h, y minus k, x minus h, y minus k, where hk is your center. So for all three of these, hk is my center. The only one where this differs is parabolas, where hk is my vertex, which we've done before in the past. So let's talk parabolas. So a parabola is, I'm going to make this thicker. It is the cross section of a cone in this awkward angle. Okay, so I'm going to do this again. Here it is. So if I were to take this plane and lay it flat, it would look like that. It would look like a parabola. So the reason that this entire section on parabolas is absolutely annoying and difficult is because we've learned parabolas through one lens. Now we have to kind of learn it in a completely different lens. So it's annoying, I know, but we got this, guys. We got this. So what is the definition of a parabola? So just like above, it is the set of all points. Again, I told you that's important. The set of all points that are the same distance from a given point, called the focus, right? We've worked with foci before, and a given line called the directrix. Okay, that is a new word for you. Direct and then RIX. Okay, so let's talk about what that means. Again, random point. So this guy right here, XY. The distance, the definition of a parabola means that the distance from the focus, there's only one focus, which is good for me because then I don't have to deal with the plural of it. So let's say that's D. And the distance from that same point perpendicular to this line down here called the directrix is the same distance. So this distance is equal to this distance. So even if I had D1 and D2, D1 is equal to D2. Now, some terms you already know. This is called what? It's called the axis of symmetry. And the axis of symmetry is perpendicular. So AOS is perpendicular to, I'm just going to write the geometry symbols, perpendicular to the directrix. Now, let's see what this looks like in that live action thingamabob that we did. So this is a parabola. And here's that random point. Here's the distance to the focus. Here's the distance to the directrix. Okay. Now, what we didn't speak about in over here is that the focus and the directrix are equidistant from the vertex. So focus and directrix are equidistant from the vertex, which we'll talk about in a second. But for right now, you need to know that this point B is equidistant from A, which is the focus, and it is equidistant from C, which is the directrix. So no matter where I move it, so notice that 2.54, 2.54, no matter where I move it, it's still going to be the same number, 2.68, 2.68, if I move it here. Now, if I move it to the vertex, it's 1 and 1 because they are equidistant from each other. So no matter what, it is the set of all points that have that same distance. I was about to ask, does anybody have any questions? And then I realized that it does not make any sense because I'm making a video. So let's talk about that distance away from the vertex. We are going to call that distance. We are not. That distance is called P. So this right here is P. Make that a little nicer. So this distance right here is called P. That means that the distance from here to here also, which is this point, is also P, but we would call this negative P because it goes in the opposite direction. But either way, what you need to know is that it is P units away from both of them. So P is the distance between the vertex and the focus, and it is also the distance from the vertex to the directrix. Now, P is equal to 1 over 4A. So I already took the time to derive what is A then. A is the same letter that we've worked with, right? So A is like y equals ax squared plus bx plus c, or in vertex form, which I have down here. This is your A, right? So P is the same thing as 1 over 4A, which also means that A is equal to 1 over 4P. So we are going to derive the standard form. So this is where it gets annoying. Standard form in conics is different than the standard form that you've been used to. Again, annoying, I know, but we got this. So again, from up top, all the way up here, when we did the standard form over here, I want to remind you that there's always that x minus h and there's always that y minus k. Also, what I want in my standard form is a p because that is important here. Let's go down. So the first thing I'm going to do is I'm going to replace that a with this formula up here, which is 1 over 4p. So that's the first thing I'm going to do, is I'm going to take this, and I'm going to do 1 over 4p instead of a, because I think it's important to do that first and foremost because we do want that p in there eventually. So we have y equals, and then x minus h squared plus k. Now what I want to do is I want to isolate this x minus h squared because that is kind of our key here. Just like all the other standard forms, there's that x minus h. And I want to keep that in there. I don't want to separate that. So the first thing I'm going to do is minus k. And so I get y minus k equals 1 over 4p x minus h squared. I still want to isolate that. So I'm going to multiply it by 4p to get rid of that 1 over 4p. And then I get 4p y minus k equals x minus h squared. That, ladies and gents, is your standard form. So I'm going to write it here. Oh, I have it written all the way already down here. Is going to be, I'm going to write the squared term over here. X minus h squared is equal to 4p y minus k. And I'm going to emphasize it still has these two parts in it. But the difference between, I'm going to write that here because it's really important. Difference between parabolas and all other conic sections is that only one variable is squared. Which you know, we've done this before, right? So we have y equals or x equals. But usually we work with y equals, right? That's what we've done. X squared plus blah, 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 blah. Or y equals 2x minus 3 squared. So only one of the variables have been squared in the past. Here it's x, okay? Where p, so we have x minus h squared. So I know that this is going to be a vertical. It's going to look like a regular parabola that we've known. So think about it like this. X is squared. X is usually squared, and y is usually not squared. So it is a parabola that we are used to. Okay? And p, again, is the distance from, or distance between the vertex and the focus. So let's talk about vertical versus horizontal parabolas. Here, excuse me, we have our, let's go with green. So here we have a vertical parabola, right? Vertical meaning it opens up or it will open down, right? That's an option. The way you'll know if it opens down or up is if P is positive or negative. If P is positive, then that means that the distance between the vertex and the focus is a positive number, so it goes up. Okay? If P is negative, it works exactly like if A was negative. If A is negative, it's concave down or it opens downward. So that says it right here. Now, what is the difference if it is a sideways parabola, right? It's a parabola on its side, or a horizontal parabola. That's really how it's said. So a horizontal parabola is the exact same thing, except your variables are switched. So think inverses, right? A square root function. This was our square root function, but it's the plus or minus square root. So it's the entire thing. And the only things that are switched are x and y. They're swapped, meaning that it is the inverse of it. So that means that it is on its side. It is a horizontal parabola. The way to think about it is which variable is being squared. If x is being squared, it's a parabola like we know it. If y is being squared, it is not a parabola like we know it. It is the inverse of it. Again, P is the distance from the vertex to the focus. If P is negative, then it goes like that. So I want you guys to look at the notes this is the notes that are in your packet. Okay, I wanted to kind of clear a little bit of it up because it doesn't give you it doesn't give you standard form and in terms of P, and I want to make sure that that is in your notes. So right here, if you printed it out, you can write it down, or you can just write it down in your notebook. So I want to write down standard form here. And you can write it from above, or you can write it here. So I'm going to write it here. X minus h squared equals 4p y minus k squared. Oh, well, y minus k, period. And then here it's the same exact thing, except it's y minus k squared equals 4p and then x minus h. Notice how x minus h is always x minus h, and y minus k is always y minus k. Those do not change. It is always going to be h and k is x and y. Vertex is h and k. We know this. And then axis of symmetry doesn't change. It's the same concept that we know. But here, I want to rewrite this. Remember we said 1 over 4a is the same thing as p? So it's going to be, my focus is going, since it's going up, my x value doesn't change. So it's x and then it's k plus p. And this, my directrix is going to be y equals k minus p. Again, it goes in the opposite direction. So here's a key thing that I think has helped me complete these. Because again, I needed to learn this separate from the parabolas that I'm used to. When y is not the thing being squared, that is the thing changing. Okay, so y is by itself. So here y is changing and y is my directrix. That is the pattern. Here, it's going to be the complete opposite, right? So I have x is being squared. X is by itself. It's not being squared. So that means that x is the thing that's not changing, or that is changing. So I have h plus p is changing, and then k, and then x equals h minus p. So x, x, and x. X is the key change factor here. I know that was a lot of information, but let's do some practice problems. Excuse me. So write each question. This is from your packet. Right after the notes, there's a problem. The first problem is write each equation in standard form. Identify the vertex, axis of symmetry, and direction of opening. Okay. When I did it, I also identify P. I'm going to do all that here because I want to show you guys how to find the directrix and the focus. So let's do that. So the first thing I want to do is get my x's together. Same concept as with ellipses. You want to group your variables, and I'm going to bring this 13 over. So I'm going to do minus 13, minus 13. So I have y minus 13 minus x squared equals negative 8x. And I'm going to bring over that x squared. We're going to have to complete the square again. So Completing the square, if I cut -8 in half, it's -4, and I square it, it's 16. So plus 16 plus 16. Let's make some room here. And so I get y, -13 plus 16 is 3, equals x minus 4 squared. That is standard form. Things we need to know. What is my vertex? I know it's going to be the opposite of -4, so it's going to be 4, -3. Again, it's negative, negative. It's the opposite of both. What is my axis of symmetry? So my axis of symmetry, this is a regular parabola, x is squared, so it's x equals 4. Again, my directrix is going to be the opposite of this, is going to be y equals. So when we get there, it's going to be y equals, because the axis of symmetry and the directrix are perpendicular. Now, excuse me. Axis of symmetry, what else did I ask for? And direction of opening. So it opens. So let's find what P is. P is equal to this number up here. Technically, this is a 1 up here. So that means that, let me show you guys how to find this. So this is a 1 up here. So that means that 4P is equal to 1. Because remember, in our standard form, there's a 4P in front of my non-square term, my linear term. So 4P is equal to 1. That means that P is equal to 1 over 4. So P is positive. That means it opens up. So because I know what P is, I'm going to do a little like mini sketch here, which is what I did for most of the problems when I did them, is I don't even need to do all this. What I can do is I know that it's going to open up. I know that my vertex is at 4, -3. And I know my directrix is here and my focus is here. My focus is always on the inside and my directrix is always like the parabola is sitting on top of it. So I know this right here is going to be, so my focus is going to have the same x value, so 4, and it's going to be -3 and then up 1/4. So it's going to be -3 plus 1 over 4. So that means that it's 4, -2 3/4. So that's my focus. And then my directrix is going to be the complete opposite. It's going to be -3 minus 1/4 because of my p-value, which is -3 1/4. So y equals -3 1/4. It always helps to make a little sketch, especially because it tells you where your directrix is and it tells you where your focus is. All right, so let's look at this problem. This is not in the graphing. So after that problem is some graphing, and then there's a problem right after, there's a page after that, part 3. Write an equation for the parabola described below. So it tells me what the vertex is and it tells me what the directrix is. So immediately I see that the directrix is y equals. So I know y is going to be by itself. So I know x is going to be squared. Okay. So I know that I'm going to have x. I'm going to write the equation down. X minus h squared equals 4p y minus k. So I start filling things in. I have h. I have k. And so I'm going to fill this in. So h is -2, so I'm going to have a +2 here, and I'm going to have a +4 here. So it's x plus 2 squared equals 4p y plus 4. But I need to know what p is. So again, make a little rough sketch, which is exactly what I did in on my little sheet. So I know that I have negative 2, 1, 2, 3, 4. Negative 2, negative 4 is my vertex, and my directrix is y equals 1, which is all the way up here. And again, my directrix is always underneath my parabola, so that means that my parabola is going to be face down. And my p-value is going to be, so it's 1, 2, 3, 4, 5. The distance between negative 4 and positive 1 is, this distance right here is going to be 5. So p is equal to 5. But I know it's going to be p is equal to negative 5 because it is underneath, it is a upside down parabola. So p is equal to negative 5. So I know I'm going to put here negative 5, and it's going to be times 4. So that means it's going to be negative 20, and then I bring everything else down. And there is my, that is my equation. What is my focus? I know it doesn't ask you for this, but what is my focus? So my focus is going to be 5 more units in the other direction. Whatever this is. So this is going to be 5 more units down. So 5 more units down from negative 4 is going to be negative 9, but it's going to have the same x value. So it's going to be negative 2, negative 9. So basically, it's just a game of figuring out where everything is. It's not a matter of, oh, I need to know all these formulas. You don't really need to know a bunch of formulas. It's understanding. The only formulas you really need to know is the standard form, but figuring out what the p-value is and all that stuff is just sketching the parabola. Now, I'm the teacher and I still draw it out because it's so much easier for me.